Hi everybody, welcome to my channel. In this session I am going to explain you Colpitt'S oscillator. What is meant by Colpitt'S oscillator, how it is going to work, what are the advantages, disadvantages, and also the applications. Previously in the previous video we have discussed Hartley oscillator. If the viewers didn't watch it, please go through that video in order to have some fundamentals regarding the oscillators. Let me explain you the Colpitt'S oscillator in this video. First of all, let me go through the objectives. So the learner will understand what is meant by Colpitt'S oscillator, working of it, and expression for the frequency of oscillations, advantages, disadvantages, and applications. It is very popular and generally it is used as local oscillator in radio and TV receivers. Here the tank circuit consists of two capacitors and one inductor, unlike the Hartley oscillator. In the case of Hartley oscillator, the tank circuit consists of two inductors and one capacitor, but here the converse of it we are going to use in this particular oscillator, two capacitors and one inductor. The purpose of tank circuit is to produce the oscillations, the required oscillations. Let me explain you the circuit diagram of Colpitt'S oscillator. Here you can see the tank circuit consisting of C1, C2 and L. So this particular path or circuit is going to form the required tank circuit, which is going to generate the oscillations, and the remaining things are same as that we have discussed in the previous. Of course, let me explain you once again. R1, R2 and RE are going to form the biasing circuit to this transistor. C input, in the input capacitor, is going to block any DC signal here, and it allows only the pure AC supply. And CE, the emitter capacitor, is going to reduce the overall reactance of this path so that the signal flow will be uniform and smooth. The RFC, radio frequency signal coil, this radio frequency coil is going to block the AC, and whatever output we are going to get here, this output is going to be given as input through this capacitor to the tank circuit. Of course, this output is amplified and hence this can fulfill the losses which are being developed in this tank circuit, thereby developing the sustained oscillations. So that is the brief introduction of this Colpitt'S oscillator. Let me go through the further slides. So the different parts are amplifier, tank circuit, the feedback circuit in the form of a coupling capacitor. Let me give you the components here that we have considered in the circuit. R1, R2, RE are the resistors, C input, CE, C1 and C2 are the capacitors. It is the radio frequency coil, L is the inductive coil, and T is the NPN transistor. And supply, power supply is VCC that we have considered here. So the tank circuit is made up of C1, C2 and L, two capacitors and one inductor. And the resistors R1, R2 and RE are going to provide the required biasing and stability to the circuit. And CE is the bypass capacitor for the emitter current. And C input blocks the DC component. The radio frequency coil blocks the AC component. So all these things we have discussed earlier. And when the power is on, so once the collector's current starts rising, it charges the capacitors C1 and C2. And these capacitors are going to discharge through the coil L, thereby setting up the required oscillations. And the frequency of these oscillations is given by F is equal to 1 by 2 pi into square root of L into CT. CT means the total capacitance, which is given by Actually these two, the capacitors are connected in series, hence the resultant will be CT will be equal to C1 into C2 by C1 plus C2. So where CT is equal to C1 into C2 by C1 plus C2. And once these oscillations across C1 are applied to the base terminal of the transistor, they are going to be amplified in the collector circuit, and again this amplified signal will be given as feedback to the tank circuit in order to fulfill the losses in the tank circuit. And whatever magnitude of feedback is there, it depends upon the values of the capacitances, capacitive values of C1 and C2. Now the phase shift, as the tank circuit is a combination of inductance and capacitance, it is going to generate a phase shift of 180 degrees, and the amplifier itself is going to generate a phase shift of 180 degrees. So put together the overall phase shift of 360 degrees, which satisfies one of the conditions of Bark-Hassan criterion, which is required for sustained oscillations. So the tank circuit generates 180 degrees phase shift, and the amplifier further produces 180 degrees of phase shift, thereby giving the total phase shift of 360 degrees. So in this way, the energy which is fed back to the tank circuit will be in phase with the oscillations. So that's about the Colpitt'S oscillators of principle of operation. And if you go for the advantages, it is very easy to tune it, and adaptability to a wide range of frequencies. Output frequency will be high. And if you go for the disadvantages, obviously we are going for a number of components, inductors and capacitors, so that it includes a little bit expensive. The cost will be somewhat more. The frequency stability will be less. And if you go for the applications part, these are widely used in radio receivers as a local oscillator, and TV receivers as a local oscillator also, for induction and dielectric heating purposes, just like that we have seen in the case of Hartley oscillator, and for high frequency applications. So these are the things we have discussed till now. Working principle of Colpitt'S oscillator, frequency, advantages, disadvantages and applications. So let me give you some quick points. So the tank circuit of Colpitt'S oscillator produces a phase shift of these are the options given to us: 0, 90 degrees, 180 degrees and 360 degrees. The option is 180 degrees. And the Colpitt'S oscillators are used in digital clocks, function generators, temperature controlled ovens and radio and TV receivers. The option is D, radio and TV receivers. And generally these are the frequently asked questions in the examinations, like operation of Colpitt'S oscillators with lead sketch, and advantages, disadvantages of Colpitt'S oscillators, and applications. So that's all for this session. So I request all my viewers to do subscribe to my channel, give your valuable feedback, which is going to support me a lot in making the videos in a better way. Thank you very much, and this is Shiva Biram signing off.